Trying to communicate in a foreign language is difficult at first, but once you learn the vocabulary, you are well on your way. Chemistry is similar. It helps to get comfortable with the language, and chemical formulas and structures are important nouns in the vocabulary of chemistry. This is Real Chem. An advantage of learning the language of a science, such as chemistry, is that the vocabulary is designed to make sense. The terms and conventions, they're designed to make it easier to discuss ideas. But the language also recognizes that sometimes we need to focus on different things. Sometimes the number of carbons and hydrogens in a molecule is the important thing. Other times, the geometry and shapes may also be important. The way we choose to represent a chemical compound depends on what we're trying to say. Let's explore. Let's use ammonia as our example. You know, that stuff they put in window cleaner. We'll start with molecular formula. This communicates the elements present and the number of atoms of each element. The molecular formula of ammonia is NH3. This tells us there's 1 atom of nitrogen and 3 hydrogen atoms in every ammonia molecule. The small 3 in the formula is known as a subscript and is shown to the right-hand side of the element it corresponds to. As another quick example, let's look at C2H6. It tells us that there are 2 carbons and 6 hydrogens in every molecule of this compound. Certainly useful to know that ammonia has 1 nitrogen and 3 hydrogen atoms, but we may also want to know how these atoms are connected to one another. This is where structural formulas come in. Here, lines represent chemical bonds, and the drawing shows us that each hydrogen atom is connected to the nitrogen atom through a single bond. But this doesn't show us the shape of the molecule. To show shape, we can use a ball and stick model, where each ball is an atom and each stick is a bond. In this case, blue represents the nitrogen atom and white represents the hydrogen atoms. This shows that the structure is like a pyramid, with the nitrogen atom on top and the hydrogen atoms forming the base of the pyramid. A ball and stick model is excellent at showing the 3D arrangement of the atoms in a molecule. We can clearly see the bond length, we can see the angles between these bonds, but it doesn't convey the size of the atoms or the size of the molecule as a whole. To show the size, we can use a space-filling model. This shows us the volume that each atom occupies. This volume is due to the electrons in the atom. Notice how nitrogen and hydrogen atoms share space between the atoms. This is because in the chemical bond, the atoms are sharing electrons. So the spheres representing the electron density around each atom, those spheres must overlap. But a space-filling model has some disadvantages. It makes it harder to see some details like the length of the bonds and the angles between these bonds. But by showing the size and the shape of the molecule, we can better envision how ammonia molecules would interact with other molecules. If we were to assemble ammonia molecules into a solid, it would be like stacking these space-filling models into a regular lattice. So the space-filling model is great at visualizing things like the distance between the ammonia molecules in the solid or even the liquid form. Going down to the atomic level is like visiting a foreign land, and it helps to become familiar with the language. We've been talking about the language used to describe chemical structures. These are the nouns in the language of chemistry. As we move forward, we'll be introducing verbs such as attract, repel, react. So explore and remember to have fun.